Hi, my name is Thomas. Welcome to Organisationsdiplomat. This is our facility in Stuttgart, and today we want to build a developer bench. A developer bench is nothing more than the necessary components you need to build an embedded device, a PCB. So you need power, you need a place to set it up. We had a great insight thanks to Jeff's ideas about the tin end racks and his home lapping, that we can use the same components as him to build a developer variant. So we went on Amazon, had a bit of a haul. Let's see what we got. This 10-inch rack we already used for our network purposes. So we had a couple of shelves and cable management. We bought a couple more things. And of course, you can also buy now 3D printed devices. So that contained all the necessary shelves and other things we need to bolt onto our 10-inch rack to put our devices into it that we need for a developer bench. The next thing that we need is power. So for a developer bench, you need 3 volts, 5 volts, 12 volts. You can use lamp power, but we have decided to go with an ATX. For that ATX, we need a couple of distribution PCBs. So the first PCB that we have is ATX via a fuse PCB to get to the various power rails. And to distribute the power rails throughout the system, we have a relay PCB with USB that contains our power supplies. To get the power to the PCB, we have a very small power strip. The power strip also has USB that we might use throughout our developer bench. So we have now the 10-inch rack, we have the power. The third thing is the mounting abilities. And for that, we are using DIN rails. DIN rails come with a various variants of components. For example, this is a DIN pluggable power rail that we are not using today. But they are also coming with this nice PCB mounts. So we can on one hand mount all the necessary components, and on the other hand we can mount our PCB under development. The DIN rail and the 10-inch racks provides us with all the necessary things off the shelf to build that developer bench very fast. With this overview done, let's continue. Let's unpack. So what is really nice over the last couple of years is that the devices are getting cheaper and cheaper. So you can now buy a lot of things that you couldn't buy in the last couple of years. And this allows now everybody to build its own developer bench. We will have a follow-up video going into the system of a developer bench. Today is just our build. So we have almost all the components done, all the trash put to the side. So let's put the 10-inch rack together. First, we need knobs because it drives me nuts to not have the device scratching all my surfaces. So those knobs are quite good. You can also use them on PCBs alone. So if you have a PCB and you don't have the right things, don't put it on, on anything, on cardboard. If you move, you can shorten out the PCB. So those small plastic knobs, you can glue them onto the PCB, and they will have a standoff. But for our purposes today, we are going to glue the knobs onto our 10-inch rack. This 10-inch rack is quite interesting. I bought it a year ago. It's only 60 euros. It has a lot of holes. It is designed by a German company to put onto the wall. I'm not going to do that. And it already comes pre-drilled with the necessary holes to mount DIN rail. So that is something that was really interesting. This is how I got to this idea, to contain the development bench within a 10-inch rack. So we put on the feet. Let's push this to the side. Grab our screws that we will need. So we put on the feet. The next step that we will do is now put on the shelves. For that, we need nothing more than a screwdriver. One of the things that is quite annoying is that because you're using the rack mount systems, sometimes even from the same supplier, doesn't mean that they will fit. So in this case, for example, the one U shelf that I have doesn't fit into the rack because of the lip. So that's quite annoying. You can also 3D print. So whatever you see today, you can improve with your own. 3D printing was not the goal for this build. So the first shelf that we will put in is in the middle of the system. So we have let's put in the various shelves to set up the device. We need 3 shelves, 1 for the power supply, 2 for the various measurements devices that will complement the development bench. Be careful when you buy shelves, even if you buy them from the same manufacturer, even if they are meant to be within a rack system. In this case, for example, this shelf doesn't fit because of the lip. So the first shelves will be placed here. Let's screw it in. The second shelf, we will just put it beneath it. That gives us 2 U of electronics space for the development of our various embedded systems. On top, we will put in the blank. Later on, this could help us to set up buttons, LEDs, devices. It depends on what we're going to do and how we're going to lay up and set off the bench. Mm-hmm. What's going on? Ja, das funktioniert doch ganz gut. So. So we put in the blank, top drawer, top shelf. So we put in the blank, upper shelf, lower shelf. For 10-inch racks, I didn't find any of the one addition. So we put in the blanks. One addition that you could do is you could place the cable mount. We're not going to do that today. The next step we're going to take is to add the power supply. The power supply is 3U high. It will be behind this mesh, and it will be placed on this shelf. So let's put you aside. Let's have a look at our power supply. The power supply comes with the power plug, the harness, and the ATX, and the supply. And what I really like about it is that it's modular, meaning we don't load up the cramped space inside with too many cables. Unfortunately, this power supply doesn't have any way to bolt it into the 10-inch rack directly. And because of the lip, we could turn it upside down, put it in upside down. From a thermal point of view, it should be okay. And you can see now our second problem. So not only aren't we able to mount it, but the power plug, the supplied one, doesn't fit. It collides now with our shelf. So now this doesn't fit. and the cable itself is way too long. So we bought alternatives. Same issue. It's now short enough for usage within the rack. So the second is now 90 degrees. And it now fits within the device. Buying special cables is always a hassle. You know, it can go up, down, left, right. The length varies. Every cable is 10 euros, so it adds up quite fast. So the power supply will be put upside down into the rack. On the side, the plug goes in. That fits within the rack. And we have enough space to plug in the ATX cable that will go up to the device for powering. To mount it upside down onto the shelf, we are going to use zip ties. So we're going to use 2 zip ties that will hold the back of the device. So we continue. I don't like how this flops down. So there's nothing to it. Can we salvage one? That would be nice. So let's try this one more time. So I like this. This feels sturdy. So going to be placed inside the cabinet like this. We have to redo. And redo. So we want to be placed like this and like this. this is how it's supposed to be sitting inside the cabinet. Yeah. Let's clean up a bit. So, we're not. All right, let's clean up the space. All right, third try. We want to place it within the cabinet that on the one side we have we're not kinking the power supply cable, and we have enough space for the other side. Unfortunately, the last two attempts we didn't quite make it. So now a bit more space. Stuff like this you can't rush. You buy stuff, it's supposed to be all in one system, right? And there's not like in Lego a game plan. So, you know, this device, I really wanted to bolt it on, but because of my components that I will put into the rack, it just doesn't fit. So I will step back, have a thought, think about how you want to solve this particular issue. So what we need is our power supply cable set. So we need only the ATX 24 pins on the one side, and we need the two plugs on the other side. Yeah. So let's bolt them in. All right. You just place it on one, place it on the other side. Here's the snap. there you go. So we know now how much cable we have on the one side, and we need the power plug on the other side. So we know that the fan is supposed to be on the bottom, sucking in the air, blowing out to the side. So we know that our tray needs to be on top. And we did do a dry fit, and it did work out at the dry fit, but we didn't use the cables. And now we need to figure out if we have enough space on the sides with the cables. This feels nice, so let's do another dry fit. Now that we have enough space, put the cables through. Don't kink. If you kink cables, trust me, later on you will search for it for quite some time. Been there, done that multiple times. Let's have a look. Here we have a cable that likes to be kinked. The power supply cable fits. We push it completely to the side. So we push it completely to the side. The cable still has so if we push everything together and don't kink the cable, we see that we have enough space on both sides, so we can push it to one side, make it a bit more stable. We want to make it stable. If we lift this up, we don't want the ATX to drop out of the bench. And if we now have a look inside, there's enough space on the side that we don't kink the cable, the main cable. Power supply will be on this side or on that side, so the cable is enough. The length of the ATX, it goes up. So from a cable point of view, from a drive, from a cable point of view, from a point of view of space for the components, we are looking very good, very positive. Now let's try for the third time to fix it into place. We have a bit of an issue. We need to slide it in and then zip tie it, and we are running out of zip ties. So let's see if we can make it happen. Get it outside. So we know that if we push everything to the side, so we know that this is fine from the point of view so So we know that if we place the grill, it will lock it in on that side. So we want to go down. So we want to have a hard corner on ATX on that side. No. So. Alright. Das sieht doch jetzt ganz gut aus. So that looks nice. Okay. I would say this is as tight as we will get. But we did a mistake, right? Because we placed that in such a fashion that it will now bump against. So that needs to be on the other side, hey? Other than that, this is a nice package. But yes. So let's try it one more time. And if the front is locked, it's also not sliding, you know, like if you move it around. Found a couple more zip ties. So we do know what we want to do. We want to have a hard corner on that side. We don't want to have any corner on the top, as we want to get close to the top shelf, hopefully not interfering anything on the top shelf. So let's use 2 more. And this time we're going to use 3. So we don't want that, because we want to be completely flat. So we want to be completely flat on this side, on that side. To completely flat outside of it. So let's give us a little. If we put a bump here, are we able to slide it back in? Let's see, we should be able, right? Just that we don't do it. Yeah, so, yeah. I'm surprised. But again, everybody can do that. You just need a bit of patience. Bit of patience, bit of thinking. And we should be set. Okay. So we want it more position. Also add a bump below, so we're consistent. So, beautiful. So now that piece of plastic is outside. All right, let's clip and put it back in. And it holds quite nice. All right. And let's take out the shelf, slide it in without the shelf. This is a package that I want to use. Like this. No need. can space U inside. Problem will be, no, you fit. And you fit. So that's always what I say. The problem is in the back, so they collide. That's quite frustrating. So the problem is this lip here is biting into that shelf over here. But we have a solution. So the problem here is if I swap them, we run into the same problem, right? We just flipped it on its head. So rather to reinvent the wheel, in the dry fit, we did it a bit different. So in the dry fit, we placed that shelf on top. I thought I would be smart, deviating from the dry fit, and now recording it bites, but that's okay. You will need half a day to assemble it, especially if you don't do it on a regular basis, and especially if you are using so many components, so many things. That's part of the game, Nothing to it but to do it. You see those polished videos, unpacking, bolting together. This is done, and here we are, half an hour, mounting an ATX topside to a shelf, zip tying it, and it just gives us struggle after struggle. But we should be now out of the woods. Let's see that nothing is binding. Nothing gives us a problem. That looks good. Fantastic. Let's screw it in. Let's not deviate any further from our dry fit. So here we have it. Power is installed. Let's take out the 1U, blank, and install it where we had it in the dry fit, right? So Now that's a lovely sound. That screw is not the nicest screw. I think this is as much as this screw wanted to go. Okay. So this is returning back. We have our ATX with the grill. We have the blank. We have the blank. We have our top shelf, just as we did it in our dry fit. To give me space on top, we are not going to put in the last shelf like that. And then also this will fit. That would be the fitted 10-inch rack. We're not going to do that just yet, because we are going to first continue with our build out. So we have our power strip, which is compact as it gets. The power strip has 2 power plugs. That's enough. Currently we only use the ATX. There's a couple of USBs. You would be surprised how many devices today run out of the box on USB. The thing that I like to do after years of learning is to use Velcro for any chemical adhesion that I'm using. Gives you the ability to take off the device and then the adhesion. I have used double-sided sticky tape for the longest time until we moved into this facility, as I had to tear down my home office at that time before we moved in here. And I used sticky tape, the good one out of Japan, everywhere, and it was a nightmare. Complete, absolute nightmare. Damaged my walls. Most of my cabinets now have residue. Pry marks where I tried to get it off, but also my devices. I broke apart a couple of devices, sticking in and prying it off. So I realized using sticky tape, you now have the ability to take off the device and re-stick it if you want to replace it, and then take off the sticky tape off the wall. And this is stuff that you learn. Chemical adhesion is fine. You're quite happy figuring out double-sided tape, finding the best tape there is, until you learn that you have to unbolt it. So let's plug you here on this side. So we can have. So one of the things that I really wanted to buy was like 30mm plug length, 15. There's only 30. So you go onto the internet and you're like, oh wow, I have so many options, meter, half a meter, under 30 centimeters. If you're working in tight conditions and you want to, make it nice and precise. Not a chance to find anything with 20. That's why those are black. We like the design, we like the length of the cable, we don't like the color. What can you do? So the ATX is mounted. It has the power plug that goes outside of the case now. You can uncoil it as you please. It can be taken off the device if you have a scenario, where you want to place it somewhere else within. That's nice. The ATX power comes up. So, as we said, this is a developer bench. This is not a test bench. This is a developer bench in a sense that if you develop for embedded devices, if you do firmware instead of software firmware, you need to place to code. That will be this place. And we said we are going to use DIN rails. So let's have a look. What else do we need?